All right, guys, this is Mrs. Strefsinski. I'm going to take you through Target 2. We're in our area unit. This is a list of all the shapes that you guys will be learning about, and I am going to provide you a PDF of these notes in case you want to print them out and follow along. So back in Target 1, you learned about a triangle. The formula for the area of a triangle is 1/2 base times height, or that's the same as base times height divided by 2, either way you want to do it. For a parallelogram, you're just going to do base times height. Now remember, both for a triangle and a parallelogram, what's important there is that the height has to be perpendicular to the base. Okay. Now a square is just a special parallelogram, so you could also do base times height, but the other way of thinking about that is taking the side and squaring it. So if I draw myself a square here, remember all 4 sides are congruent, and so if I call that S, you're really doing the base times the height, or the side times the side, which is side squared. Rectangle, again, just a special parallelogram, so you're just doing base times height. You might have also seen that written as length times width. Okay? So the 2 shapes that we're going to do today are trapezoids and circles. Those are the 2 new ones that we'll be adding. Okay, so we're going to look first at a trapezoid. Okay, so to find the area of a trapezoid, you're going to do 1/2 of the height times base 1 plus base 2. Okay, so in this diagram that I have here, again, just like a triangle and a parallelogram, the height has to be perpendicular to the base. Remember, that means it forms a right angle. So the bases are the 2 sides that are parallel to each other. So in this diagram, I'm going to use these arrows. Remember, those show parallel lines or segments. So I'm going to label this top one base 1, or B sub 1, and the bottom one is base 2, or B sub 2. Okay, so to find the area of a trapezoid, we're going to take half of the height, and we're going to multiply that times the sum of the bases. Okay, so that's our formula for trapezoids. All right, so here's our first example problem. We're going to find the area of a trapezoid that has a height of 12 inches and bases that are 38 and 44 inches. Okay, so I'm just going to label this. So the height is 12 inches and the bases are 38 and 44 inches. Okay, so when I'm calculating area, I like to show 3 steps. The first step I like to show is the formula that I'm using. So that formula we just saw is 1/2 the height times the sum of the bases. Okay. Then in the next step, I like to substitute in what I know. So I know that the height is 12. And then for base 1 and base 2, we're going to put 38 and 44. And it doesn't matter the order in which you put those. Okay. And then the third line will be your answer with units on it. Okay. So I'm going to bring in my calculator. And whenever you're putting a fraction into your calculator, you really want to put it in parentheses. So I've got 1/2 times the height, which was 12, times the base 1 and base 2 were 38 and 44. Okay, so that gives me 492. So if I go back to my paper here, 492, and my units will be inches squared. Okay, so that'll be my final answer for that problem. Okay. All right, so let's just focus on this example problem here. So we've got trapezoid RSTU, and it has an area of 935 square centimeters, and we're going to find the height. So I still like to do 3 lines of work here at a minimum. So I'm going to write the formula for the area of a trapezoid. So it's 1/2 the height times the sum of the bases. And now I'm going to substitute in the values that I know. So this 935, that was the area, so that will go here. Okay, and then I've got 1/2. They're asking me to find the height. So in my equation, I'm going to leave height as a variable. And then I can see my bases are 30 and 55. Okay, so what I have to do here is use algebra to solve for the height. Okay, so I'm going to go ahead and simplify what's in parentheses first. And that will give me 85. Okay, a couple different ways you could go from here. I'm going to multiply both sides by 2 to get rid of the 1/2. So you could either divide both sides by 1/2 or you could multiply by the reciprocal. Reciprocal means you're flipping the fraction upside down. So I'm going to multiply both sides by 2. So if I do 2 times 935, that gives me 1870. And then I have the 85 and the h. So right now I'm multiplying 85 times h, so the opposite of that is to divide. So if I do 1870 divided by 85, that gives me 22. Okay, going back and looking at our units, we're dealing with centimeters, so that will be my final answer there. Okay. All right. So next we're looking at circles. Okay. So I've got a circle drawn here. This would be the radius. So the area of a circle is pi r squared, meaning you're doing pi times the radius squared. So that's our formula. Okay, we'll look at a few example problems. So for this first one, this 14 centimeters is the diameter. Okay, that means that the radius is 7 centimeters. So I'm going to write my formula first, area equals pi r squared. And then I'm going to substitute in that my radius is 7. So notice here we're just squaring the radius. So if you take 7 squared or multiply it times itself twice, that's giving you 49. So my answer is 49 pi centimeters squared. So you'll want to pay attention to Math Excel. They might say find your area in terms of pi, meaning your answer has a pi in it. So that would be your answer in terms of pi. If they say to find your answer and round it, then you need to use your calculator. So if I bring my calculator into my screen here, okay, I'm going to do 49 times, okay, and then the pi button is right here above the caret button that we use for exponents. So I need to hit second and then pi, okay? I would recommend using that pi button as opposed to using 3.14 because 3.14 is an approximation. Here, when you use the pi button, you're going out more decimal places, so you're going to get a more precise answer. So if this said round to the nearest hundredth, that is 2 decimal places, so that's about 153.94. So we'll go back to my paper, and I'm going to use the squiggles for approximately 153.94 centimeters squared. So again, if you're dealing with Math Excel, just be sure you pay attention to those blue directions. They usually tell you how they want the answer. Okay. We're going to do one more, even though there's another one on my page here. I'll leave that for you guys to do if you want for extra practice. So here I have a radius of 7. So area is pi r squared. So that's pi times 7 squared. This one turns out to be the same. Oh well. All right, so that's going to be 49 pi. Only thing that's different here is my units are inches. So that'll be inches squared. And so that will give me the same decimal approximation at 153.94. Oops, but it'll be inches squared. Okay. All right, let's go ahead and do this one since it ends up being a little bit different. So they're still giving me the radius. And again, I really like when I do this to have 3 lines of work again. So I write my formula first, then I substitute in the values that I need. So I just need that the radius is 4. If you write this in terms of pi, 4 squared is 16. So that will be 16 pi My units are millimeters. Remember to put the squared there because area is always in square units. So now if I go to my calculator and I do 16 times pi, and I round that to 2 decimal places, that's about 50.27. I'll go back to my paper. 50.27 millimeters squared. Okay, so again, just pay attention to the directions on Math Excel and how they want you to leave your answer. So real quick, if we go back to my formula sheet and fill in these new formulas that we just learned. For a trapezoid, you're doing 1/2 of the height times the sum of the bases. Remember, sum means adding. And for a circle, you're doing pi times the radius squared. All right, so hopefully you guys feel confident finding the area of a trapezoid in a circle. Feel free to reach out to your teacher if you have any questions.